let's go ahead and get started. It is 7 o'clock on a Monday, which means it's time for Model Monday. We're trying new things this year. So our first project of the year, we were kind of doing surfaces and making a fake, or not a fake, an actual tool, a money shooting tool. And we kind of wrapped that project up last week because otherwise it would become a 27-part series on making donuts. And even though those are great, you guys don't need to see that. You don't want to join me live for an hour for 27 weeks just so we can make one project. We're moving on. So for the next couple weeks, we're going to be doing dipping our toe into the electronics area. It's going to be super fun. I'm excited. I'd like to work electronics into more of our projects because, that's an area of nerdiness that I go down. So I'm going to force you guys to join me. Ha ha. Like I said, I know we got fellow electronics nerds. Mike, you're electronics nerds. Harold, you're electronics nerds. And David, who's joining us today also, budding electronics nerds. So with that all being said, let's get started. So I'm going to open up my data panel here because I would like to start a new project. So I'm going to click on my home icon here and go back to the home view in my model or my Fusion 360 organization over here. And I'm just going to go ahead and click on this new project button. And the thing we're actually going to make is the kind of thing you see behind me. So we got all these like blinky lights over here on my shelving. We're going to make a little blinky light board. So I'm just going to call this LED strip control. Yeah, LED strip control. That sounds good. And we've got our new project named, and it's going to stick itself in my growing list of projects here, and I'm just going to double click to open that project. Now, the first thing we want to do here is import some parts. So we're going to be needing to make this out of real life parts, and I'm getting all of my real life parts from a place called DigiKey. So let me just kind of show you their website real quick just so you know what that looks like. This is DigiKey right here. So we're going to be importing two parts into the electronics area before we can start using them. So we're going to find this part right here, and which is an Arduino Nano. Part of the joy of using DigiKey is trying to figure out how to find things on DigiKey, because as you can see, this does not say Arduino Nano as the name of the part. But it is indeed an Arduino Nano IOT 33. It's a nice little board. It's one of my favorites. And then the other part we're going to use is a little board connector. So again, super fun part to find. But JST makes great little connectors, so I kind of started there. In order to download these files, this is where you order the parts for real in MeatSpace, I guess you could say. And down below, they have links to, if we scroll all the way down here, they have models, EDA and CAD models that are made by a company called Snap EDA. And I happen to open up the individual pages for each individual boards here so you can see the kind of thing we're looking for. We're looking for these board layouts and schematics. Now, you don't need to go to this website to do it because Snap EDA thankfully makes a Fusion add-on. So before we get started here, we're going to have to add on that Snap EDA add-on. Gosh, I'll have to remember how I did that now. So I am going to go to my utilities section, and you can see I've already got it added here. It's called Snap EDA. But to add it, if we go to the add-ins section and then go to the Fusion 360 App Store, then it will bring us to the Fusion 360 App Store. Now this just opens up a browser, and in that App Store it's got a little search icon, and we can type in Snap EDA in that search window there, and then we've got a app that we can download, whichever version you need, so Windows or Mac. And if you click download, oh, it'll make you sign in. So, gosh, is everybody gonna see my password, or is it gonna?
Don't worry, I'm not looking.
Okay. Well, the downside is I record this for the YouTube as well, so oh, good. Because I definitely use a different password for every website I go to. So, all right, so I'm going to download that. Again, I've already downloaded it, but I'm going to give you guys a minute to download that as well. For me, it's going to take 30 seconds, but let me know how you guys are doing in your downloading fun there.
Successfully downloaded.
Sweet.
And hopefully installed?
So you'll have to install it next. So you just install it by double-clicking it. So wherever it downloads to, you just have to double-click to open it. And then I am getting this lovely error on my Windows machine, and I will share it with you now. So here it's like, Windows has protected my PC. Oh, thanks. But really, go ahead and open that. So I just have to click on the more info, and then it'll say, hey, you want to run this anyway? And I do indeed want. I'm not going to run it anyway, but you should. And then when you click run anyway, it will do an install thing for you. And I'll take a little pause here again and let you guys kind of finish up that install there. And then once it's done installing, I had to close Fusion and reopen it. While you guys are doing that, I'll kind of share with you the rabbit hole that I've been down so far in Fusion 360 electronics here. So my initial thought was to try to make this with an ESP8266, which are like dirt cheap. They're like $4, which is awesome. But I could not get my board to work, and I think I've got a voltage regulation problem. So I thought I could get away with powering it with 5 volts. However, that does not seem to be the case because I burnt out a board. Here's my first attempt. And I've also been making my own boards myself on my resin printer, which is a cool, fun technique we'll talk about later. Yeah, I need a voltage regulator because I'm burned out some boards. So we're going to use a board that doesn't require 3.3 volt logic or power. But it will cost more, which is unfortunate. But it is what it is. And the kind of fun thing about doing things in Fusion 360 is I've been using it for the Grow Beyond Earth project that I'm working on, and you can make boards that are funky shaped. So here's a funky shaped board. This is one of the footprints we're going to be using in Arduino Nano here. But it's kind of cool that you can make your own boards that are funky shaped, and then you can have a whole bunch of those boards somewhere. You can order them from China, and they just come in the mail. It's fantastic. So that's that weird shaped board that you see on the screen there. Designed in Fusion, and there are the nice little pads hanging out. So, all right. Were you guys able to download successfully? And you reopened Fusion?
Successfully downloaded and installed.
All right, cool. Great. Thank you. All right, Mike, are you following along with us too?
I'm following along. I only have one screen here. It's too clumsy for me to do and watch at the same time.
Okay, I got it.
I'm spectating.
Okay, right on. You know,
I'm catching up, but don't worry about me.
Okay, cool. And, feel free to pop in with questions if you got them. I don't mind slowing down at all if you got a couple of questions. That's why we do this live and in person. Well, I guess not in person. We do it live, but not in person. Hopefully we'll be back to in person soon. When the makerspace goes back to in-person meetings, then I'll start offering class in person again.
Wonderful.
I gotta find that project. And I'm not sure what the plan is for the makerspace to offer in-person classes, but hopefully it will be soon. All right, so now that you've got that Snap EDA installed, now when you go to your utilities section, you'll see that little Snap EDA icon there, which is cool, right? Hopefully, we're good. You see it? Sweet. Okay, good. All right. So if you click on it, you can open that plugin. Now, for me, this has been a frustration with Snap EDA is it's probably open because I clicked on it, but it's probably showing me somewhere in the background. So I gotta spend some time looking around and trying to find the window. Where did you go? You're not over here. And sometimes I have to do the crazy step of closing Fusion and then reopening it, which is apparently what I have to do right now. So if I close Fusion and then reopen it, it's frustrating that it's like this, but I think it's worth it to have all these board footprints so you don't have to make them yourself, because making your own board footprints might be something we try in the future, but it's not something I want to start doing, that's for sure. So utilities, Snap EDA plugin. There we go. Now it's opening. It's just opening out another window. So there it is right there. So now we could search for components by name. And the names are going to be those weird names that it was showing me on DigiKey. So yeah.
Carl, before you get too far, did you need to create a special Snap EDA account?
I may have signed into my account here. Yes.
Okay, that's all.
Yeah. Okay. Cool. I'll give you guys another second while you guys sign into an account there. So that's a good call. Thank you. But yeah, I'm probably automatically signed in every time now, so you won't need to do that every time you open Fusion and use this. But you'll probably need to create an account and sign in the first time. And then hopefully it's easy for hopefully it's pretty painless. I don't remember my process. It's been a couple of weeks since I started prepping for this class here. But the first part that we are going to add is this ABX00027. So again, this is the Arduino Nano IOT 33. I like these Arduino Nano boards a lot, and this Nano 33 IoT is great because it's got Wi-Fi built in. So that means we can update our boards without plugging them in. So for my use case, I've got them on the lights in the background here, and I can update these wirelessly, which is fun. So that's a cool thing to add. Yeah. All right, cool. So if we just click on this part, there is a simple just download button right there. And if we click on download and say import part, it's just going to do that in the background. And it just does that and opens up a little library here. In theory. Oh, yep. Okay. So, and now the part is over here in the content manager. If I just double click on this, this is the schematic, and it's also the board layout, but it's not showing me the footprint right now because, but the footprint exists. So you'll just have to trust that. Go ahead.
Sorry, Carl. I am getting a error no 2D file when I hit the download button.
Cool. So in Snap EDA, do you see icons like this here?
I do.
Well, try it again. Or like try closing the window and reopening it.
I'll try that. I'm going to start Fusion over again because Snap EDA doesn't want to open now.
Oh. And sometimes it's a window that appears in the background. So when you, yeah, if it doesn't work for you, we'll take this as a learning opportunity because there's a second way that you can import things, and maybe we'll just go through that anyway. So yeah. In fact, while you restart, I'm gonna make sure I got my links ready to send out. If we go down that road, so I'm gonna put in the chat a couple of links to Snap EDA to the two parts. Oop, that's not it. This is it right here. So these are the two parts that we're going to be needing, and I'll put those in the chat. And then I'm going to say download. Do I have to switch my? Yeah, and I'm going to import the part, and it worked for me. And Harold, chime in when you restart if it's still not working for you.
Yeah, I fully restarted Fusion, got back to the Snap EDA, and it still did not want to. It was still giving me the same no. I think it said no 2D file.
Yeah, that's
That was a
interesting.
weird thing for it to say.
Yeah. So there are 2D files and 3D files in the electronics CAD world. The 2D files are, I'm going to say don't save here either. I'm going to close this and say don't save because I'll show you the second way to do this. The 2D files are schematics and pad layouts. So the layouts of the pads on the PCB. And then the 3D files is obviously like the shape of the thing, right? So So the second way to do this is if we, in the chat, if you find I put a couple of links. And the first link is to that Arduino board on Snap EDA. So I can, let me make sure I'm sharing the right screen here. And so here's the part on Snap EDA's website. If we just scroll down, we can see download footprint and symbol. So we're going to download the footprint and symbol. And then if we scroll down here, there is this Autodesk Fusion 360 option in the little window that pops up. And it's downloading a .lbr file. So in my downloads folder now I have an ABX00027 LBR file. I'm going to go ahead and download the second part that I need as well, which is that second link in the chat. And that second link is a link to this little connector. So we'll do the same thing. We'll download the symbol and footprint for that B3B SM4TBLFSN, which is not a mouthful at all and totally makes sense probably. So we're just going to go ahead and download that as well. Now it's kind of handy there. They show you this like learn how to import thing. But thankfully for you, I did this in advance. So once you've got those two files in your downloads folder, now we can come back over to Fusion here. So the way that we do this is in the File menu. I think we click on New Electronics Library. And now, oh, this isn't right actually. I lied. I'm going to close that. We want to do New Electronics Design. And then if I click on Reference Schematic, I'm just going to kind of jump ahead a couple of steps because, nope, this isn't it either. All right, we're going to utilize that link right here where they said learn how to import. Launch Fusion 360. From the File menu, next to the data planet, click on File, click Open, and then Open from my computer. And then I just have to open that file. So from the File menu, we just click on Open. And now I choose the Open from my computer option. And I find that ABX0027 LBR file, and I click Open. And cool, there we go. There it is right there. So there's our part. So now we'll save this. So I'm going to say File, and I'm going to save it. I'm going to save this in my LED strip control location. And in fact, I'm going to keep it the same name. Like, part of me wants to change this name to Arduino Nano. However, that may not be the best idea because if I'm going to buy these on DigiKey, this is what I'm going to want to search for. So I'm going to keep the name the same, even though that hurts my soul in some ways. So I'm just going to go ahead and click on Save into my LED strip control folder. And then I'm going to do that again. So I'm going to close this library file. I'm going to come up to File and then click Open. I'm going to open from my computer, and I'm going to find that B3B PH connector and click open. And here again, it's going to do that same thing. I can double click on this and see the schematic, and my footprint is right over here. And I'm going to save this as well. So I'm just going to say File, Save, keep that same name because that's what I'm going to search for on DigiKey when I go to buy these parts. And I'm going to click Save. All right, so now that we're halfway done with class, we can actually start making a thing. So the way you start an electronics project is in the File menu. If we just say New Electronics Design. So I'll go ahead and click on New Electronics Design. Now, we kind of start with a blank screen here. And the first thing we want to make with our electronics project is a schematic design. So we're going to create a schematic for what we want our board to be. And that's going to be fairly simple for us. So if we go ahead and it's going to start looking complicated, but it's going to be pretty straightforward. So I'm going to come up to the up to the top here. And I'm going to choose from the top left-hand corner this new schematic icon. It's funny, it's great all the tooltips still work here, so if I hover over things, I can see that I've got all my tooltips. So tooltips are still handy, especially in this electronics area when it's a new area for us. Click on New Schematic. And now we've got a schematic to start creating here. Now, this is where having multiple screens or a larger screen comes in really handy. I'm going to shrink down this inspector and things over here. And I'm going to shrink down this design manager over here as well. Because this area here is where we're going to start laying out our schematic. And in order to lay out our schematic, we have to place some parts. So there's a lot going on here, but what we need to focus on right now is just this add part icon here. Or if we click on the place library and choose, or place menu and choose add part. Now we get this window that pops up. And in this window, we can find those parts that we just added. So at the very top of my list, because mine is listed alphabetically, if I spin down the little triangle, hopefully you see that ABX00027, which is that description, is Arduino Nano 33. So this is the first part that we're going to add here, and I'm going to go ahead and click on, once I have that, spin it down and then choose the part from inside of this kind of folder. I'm going to go ahead and say OK. And now as I move my mouse around my drawing view, I can click at any point to place this part in my drawing. And once I do, I only need to place one of these parts. So once I've got that part placed, I can hit the escape key, and the escape key shoots me back into my add part window. It just kind of is handy to add all of your parts first, or maybe add quite a few of your parts first, and then come back and start connecting the things together, which is the next step here. So now the next part that I'm going to add is this BP or B3B PH connector. It's interesting. Oh, okay, all right, and then I'm going to click OK here to add this part, and I'm just going to put it somewhere off to the right side of the board. I'd put it on the right. It might save you some steps later. And maybe we'll just talk about those steps anyway. So, all right, so I'm going to place that part. And then instead of hitting the escape key, if I just say OK, Now it knows I'm done placing parts. So I just clicked on the little OK on the little window that used to be popped up here. And now I can see I'm done placing parts. Now I'm going to zoom in here. And we've got 3 pins. So this is kind of a representation of all the pins that we have available on this particular Arduino. So let's talk about moving stuff around, first of all. So these parts, I can click on them and I can move them around. So if I need to move them around on the drawing, that's something we can do. And you have to, I believe, yes, you have to, in order to move the part, you have to click on the right part of the part. So I can't move this part by clicking on this line over here. The only place I can move the part from is the little orange X that's usually in the middle of the part. So on this little connector here, the little orange X is right behind the number 2 in the rectangle there. And if I click on that right there, then that'll let me move this part around. Same thing here with this Arduino board here. So I can't click and drag on any part of this. In order to move it, it says group is empty. But if I hover over the right part of this part, which is the center of this where there's that little orange X, then I can move that around. We can also rotate these parts, and that becomes handy. We probably won't need to do that here, but if I needed to, I could click on the place, from the place menu, I can click on this little rotate icon. And again, it won't work if I'm clicking, oh, it did something there. It gives me a little error if I'm clicking, on random places of this part. I gotta click on the right part of the part in order to, the right area of the part in order to actually rotate it, which is again, that little orange X. So if I click on that little orange X in the middle there, it rotates it around in 90-degree increments. But facing having these pins face each other is where we want to be probably. All right, so now you know how to move some parts around, you know how to add a couple of parts, you know how to rotate them. Let's connect some parts here. So in order to connect the parts, we'll use the connect menu. And we are going to connect them using a net. So a net are those lines that connect parts together, kind of tells the schematic, tells everything in electronics, what connects to what here. So if I go ahead and from the connect menu choose that net option, I've got a net window that pops up here. Again, screen real estate is at a premium when you're using this electronics workspace here. I'm going to connect my ground pin on my Arduino, which is down here in the bottom right hand corner. If I click on that icon, now I haven't clicked and dragged, I'm just clicking and moving here, and I'm going to click and drag or click and move until I get roughly lined up with the pin 3 of my connector. And I'm going to place a little corner there. So you can see now I can connect it in like a fairly straightish line. This is an area that I could be much better at when I'm making my schematics. Ideally, you want to make these net lines look really simple so they don't cross over each other. And I find it difficult sometimes when you have a number of components to make sure that you don't have things that cross over each other. But you just got to connect the dots a little bit. In fact, we're going to have that problem right now because the number 2 spot on my line, I want to connect to my 5-volt pin. And my 5-volt pin is, I've got a 3.3 volt pin. How come it's not calling out? We're gonna connect it to the voltage input, so the VIN. So I've still got my net tool. I've still got this window, which is my net tool, open here. So now I know I can come up to my VIN point, And I'm going to do that same thing. I'm going to click and drag out a little bit, and then I'm going to place a little corner there, and now I can move this down until I get roughly lined up with the number 2 pin here. And now I have to make sure that I get that little blue circle. So that blue circle, when I hover the net over the pin, is telling me that it's actually connecting those parts. It's connecting that pin to that pin. Now the last connection that I need to make is from my number 1 pin. My number 1 pin is going to be the data pin on my LED strip. And we're going to connect that. You can connect it to any of these digital pins, but I'm going to connect mine to number 2. So I'm going to come up here and maybe cross over my net after. Something that's important here to note is, let me do Control Z a couple of times. If I grab my net tool, and when I'm trying to connect to D20, if I accidentally click it on that net, now it's made a connection here. This is a connection point between these 2 nets. So right now in this configuration, pin 1 and pin 2 on my connector, this connector is going to go to our LED strip, are both connected to the voltage in. And we definitely do not want that. So I'm going to do Command Z a couple of times. And now you can see the difference between a pin that just crosses over the net like that does. See, there's no little blue or teal circle at the joint there. So those things are not actually connected. It's just one of them. Wires cross over each other. Does that make sense? Yay? Nay? Cool? Happiness?
Making sense.
All right, good deal.
I'm with you.
All right.
Looks good.
Perfect. Thanks, guys. All right, so now I'm going to say OK. Now we're done with this schematic. Yay! We did a thing. So I'm going to go ahead and save it. So I'm going to go ahead and from my save menu here, it automatically says schematic there, but I'm going to put some words before the schematic. So I'm going to keep that schematic name, and it's going to be my LED strip control schematic. And I'm going to save this LED strip control schematic in my LED strip control project. And I'm just going to go ahead and say save. All right, now that we've made our schematic here, we can turn this into the board layout really easily. So up in the very top left-hand corner, there is a switch menu, and the only option in that switch menu is switch to PCB document. And that is indeed what we want to do. We want to make the PCB document for this schematic. So if we click on that option, it's going to open up yet another tab up here in the top. And we've got both of our components kind of hanging out. And then we've got a board. And here I'm going to do that same kind of thing. I'm going to shrink down our side windows so we can see our board a little bit more. We've got both of our components here. And we've got a board already kind of, I don't know, laid out for us, let's say. So the same rules apply here as applied in the schematic when moving things around. So I can't move around the board from the side. I can only move around the board from that little white X at the middle. So if I click on that little white X and move it out onto my board, see, some places it doesn't want to be, but some places it'll let you move it to. And I'm going to put mine near the bottom corner. close-ish. Now I'm going to do that same thing with my little connector pad here, right? As I'm going to hover this and move this out and put that close-ish to my board, because it's nice to have a small board if you can get away with that. Now you can see there are white lines that are already drawn connecting our parts. And if I move my board in a different location, you can see those lines a little bit more apparently, right? So we've got a ground pin. Gosh, do I need to flip this around? Nope, I think that'll be fine like that. So I'm going to move it towards my bottom here, and then now we can start connecting these, the dots. Go ahead.
So Carl, in the schematic, you didn't draw it with those lines crossing over the Arduino.
Correct. So and that's a great point. So the schematic pins don't necessarily coincide to the placement of where the pads are on the actual board. So, you know, in the Arduino schematic here, you could see that like we've got a lot more pins on one side than we do on the other. So there are probably 5 or 6 more pins on the right side of the board. And in reality, it's symmetrical. I don't know why that particular schematic is laid out like that, but it is. Okay. So it'll be something you'll have to be conscious of. And something that I do sometimes is after I've got a board, after I've got a schematic done.
This is the physical representation?
Correct, yeah. So this is the PCB, the actual physical representation of what the Arduino looks like. Okay. And oftentimes I'll realize that something is different here, and I'll bounce back over to the schematic and go, all right, well, maybe if I run it to pin 10, because my data pin could be any one of these pins. If I run my data from pin 10, then it won't have to do some crossover stuff, and so sometimes there's some back and forth that happens for sure. But we can start connecting these dots here, and though these net paths that we see in white, now we're going to make routes out of those net paths. So from the route menu, if we just come up to manual or route manual, and now I get my little route box here. Now the trace width here is not super important for this case. I'm going to bump mine up to 16, and you can do so as well. Just I don't know what that is 16 units of, frankly, but they're pretty small. 16 smallnesses, let's call it. And I can click on one of my pads here, and now if I move my mouse outward, you can see that it starts to both make a little route and show me the pad that it needs to connect to. So if I bring this off to the side and kind of get close-ish to that pad, I believe that's going to be my D2 pad. And now when I hover over the actual pad, the way I'm making a connection is difficult to see here because it doesn't expand. Well, maybe it does get bigger. You can see I get a little X. So here I'm not making the connection, here I'm making the connection. And this is a really specific thing. So here the pad is not connected, here the pad is connected. Now in reality, if I were to click here and like print out this board, it would be fine. But it's nice when the software can recognize you're actually making a connection. And it gives that route a name. So the name of this route that it has just made is $3. Every route will have their own unique name, and that's not really important for this particular class. It's just something to have some knowledge about, is each route has its own name. And if I wanted to see that name exists here in my inspector window, right? Do I have to click on it? Yeah, if I click on one of the little routes there, and then I scroll down, you can see its name here. So names that routes that have the same name are connected. For example, ground or common will often have the same, will always have the same name. So you know that all the grounds are connected. And it names them the same name by default, so you don't really have to worry about that. But it's just something to have some knowledge about, like I said. So let's finish up connecting these other routes just like we did that first one. So I'm going to click on route, and then manual route. And then I'm going to move this window off to the side here, excuse me. I'm going to connect my next pin in. Is going to need to go all the way across my board, apparently, and I can either come in between the pads over to this pin, or I can come around. Did I? You know what? Let's do this. So on this board, this will be a board that we can't make ourselves if we do it this way, but for the sake of class, I'm going to show you that you can make a board that has more than one layer. So sometimes PCB traces run on the top of the board, sometimes they run on the bottom, and if we wanted to avoid having a problem of routes crossing over each other, in the schematic view, routes can cross over each other and they won't be connected. In the board view, routes that cross over each other become connected. So the only way to avoid that is by switching to another layer. So if I switch from the top layer to the bottom layer, these are pads, so they won't let me connect them. Let's switch back over to the top. Let's run one more of these pads. Let's run the far right pad over. So I'm going to go ahead and click on route, and then route manual. I'm going to run a route from the far right pad, and I'm just going to come down and over a little bit just to give myself a little bit of breathing room here. And then I can come over and connect to that ground pad there. Yeah, and then this middle pad must be my 5 volt. You know what? I've got a ground on the other side. This is the joy of, this is kind of like a puzzle, right? So instead of running to this ground on this side, because this board has 2 grounds, so you can see this pin is connected to this pin over here. And if I zoom in, it's not going to name that at all. Sometimes on these boards it names it ground, but it is not. But I do happen to know that these 2 pins are both ground. So to avoid having to do 2 layers, if I run this one down the side here over to the ground pin over here, then I can use run the middle one kind of next to it and not have a problem with things crossing over each other. And that way this is still a board. Now, this is still a board we can make ourselves, and I think that that's kind of the fun part here. So now, if we wanted to, in this case, because the last thing that I'll show you, I think, in this class here before we wrap up is, in this case, both of the components that we are using are surface mount components, which means they don't go through the board at all. Some components are through-hole components, right? So let's see if I can find an example of a through-hole component just hanging out on my desk here. Here we go. Here. So this is a motor driver board, and this is a through-hole component. So it's got these pins that are meant to go through the board, and then you solder them from the backside. Both of the components that we've added are surface mount components, so they don't have any through holes to them. So if we wanted to route one of these pins, one of these surface mount pins, to the back of the board, and then run it on the back side, we would need to use something called a via. So a via is a little spot on the board, and here, this is not something that you guys have to do, but I just kind of want to demonstrate just for fun, because sometimes they are necessary. I think it's kind of fun to try to figure out how to do it without vias. But we can draw one of these lines that we can start our route and get as far as we can, and then go, all right, if I want to cross over, I got to go down in the bottom here. So if I click in the fan out section, fan out menu, if we choose this via option, and I place that via right on top of the end of that route that I just made there, and then I'm going to place another one near where we need to go to, because we're going to go down to the bottom of the board with that via, and then we're going to come across on the bottom of the board, and we're going to need to come back up over on this side. So I'm going to place one more via and say okay. Now, you remember before I was mentioning that routes have a name. So the name of this route is, if I move down on my inspector, it's $2. You can see it's on the top layer. And the vias also have names. Now, because is that the name of the via? Nothing selected? It's not letting me really select that via, but I placed it right on top of that route, so my guess is that one is fine. However, this one down here, if I want to be able to use this via in this route, I have to name it the same name. So I'm going to click on, it wants me to move it. I don't want to move it. There we go. So now I've got it highlighted. It says properties of via. And if I scroll down here, right now this is set to $4. If I want to use it in the same route as that other via, I have to name it to the same route. So I have to change it to $2, and it'll give me this little pop-up window. It says, hey, do you want to connect 4 and 2? And you want to say yes. And now you can see that net goes through, and I'll be able to run a route that connects those things. All right, and to run a route, if I want to run the route on the back of the board, on the bottom of the board, if we switch here in the top left from top to bottom, and now when we choose to route a manual route or route manual, now it'll let us connect these things, and we don't have to worry about this pad here, even though these are overlapping, because we're running on the back of the board. they won't be connected. And now the last thing I'm going to do here on this board layout is I'm going to switch back to my top view. And I'm going to route one more time. And now we're all connected. So, the last thing that we'll do here in this board layout section is just to shrink down our board. So the green lines of the board, we can just click and drag on them, and we can drag in and make this much smaller. So we only need to be as big as our board is. Now you can see that if I start moving askew here, we can easily make a board that's not square, and that is totally fine. You can make a board that's not square if you want to, but or not square. It's not parallel. It's not a rectangle anymore. It would be a rhombus at that point. So be conscious of that when you're moving them around. If you don't want to make a rhombus, then try not to. All right. So, go ahead. Do you have a question, or are we just random laughs at my rhombusness?
I was just snickering. It's
Okay, cool. Right on. All right.
I thought I was on mute.
All right. So now we're going to go ahead and say save. So I'm going to save this, and I'm not going to save this as the schematic. I'm going to save this as the PCB. And I'm going to say save. So now we've got our schematic, we've got our PCB, and for the last trick of class here, if we come over here to this push to 3D PCB button in the top left-hand corner, well, I'm not going to check any of that because I don't think it matters a whole lot, because I don't think we have any canvases. So I'm going to say OK. And it gives us a very mediocre PCB. We'll improve this in the next class by actually adding the 3D components. But for now, that's going to be it. And this is yet a fourth file, believe it or not. So I'm going to click Save here. And this, instead of PCB, I'm going to call 3D PCB. So this is yet a fourth document that we've opened up here. And you can see all four documents that I've got are open across the top. We've got our 3D PCB, we've got our 2D PCB, or 2D board, we've got our schematic, and then we've got the one document that kind of holds all four of these. It is the first, is the file that it created when we said File New Electronics Design. That's this file right here. So it's kind of all of these three documents in one. I'll mention that it's really easy to get to your 10 document limit in the hobbyist edition of Fusion 360 when you're doing this electronics design stuff. Because like I said, we already got 4 documents here, and if we're going to add parts and enclosures, you get to that 10 document limit real quick. So that'll be a fun management thing for later. Does anybody have any questions about how far we got today?
So one question from David here.
Yeah.
So the PCB you created, that would be, you're plugging the Arduino into that.
Well, the Arduino kind of
Is that right?
sits on top of it. So the Arduino Nano with the IoT 33 here, I've got one sitting over here. When you get them from DigiKey, they don't come with the pins soldered on. So you can choose to solder those on yourself or not. And this board also has what's known as castellated pads. So That's what
Hey,
we
Carl,
can
we
get.
can't actually see you.
Oh, cool. Let me make that so you can do that. And if I switch to this, I'll be nice and big there.
There you go.
So this is the board here. This is
Yeah.
the Arduino Nano, right? And so it doesn't have the
Right.
pins on it. And what I mean when I say castellated pads is, if my camera will focus, which it will not, the pads go all the way to the outside. So they're kind of there's metal visible on the outer edge of this. And that means we can solder this to the surface of something. So it'll actually sit
Oh, okay.
right on the surface of a board. Here, I got one right here. So here are some pads.
Yes, my nanos have had the pins on them, and we just plug it in the breadboard. So I haven't
Sure.
done a PCB. So
And then it'll just sit on the board just like that. And we'll
Okay.
solder those pins right together.
You can solder that. I think I need a microscope and little tiny fingers and Waldos.
You know, that's a good point, Mike. And you know what we might do is, I bet we can use what we've got here in Fusion to make a solder mask. So you don't have to solder by hand when you're soldering surface mount components. You can put like a solder paste. You can kind of like screen print almost a solder paste out onto a board. And then you can use a heat gun, like a hot air reflow gun to melt your solder. And then if you use a mask, then you can get away with doing real tiny little solder joints for little tiny surface mount things. So
I'll ask you to solder it for me for a couple of beers.
I'm happy to do it for free, sir. Yeah, for sure. But yeah, so that's it for today. We'll
Thank you.
continue next week and add our 3D parts, and then maybe we'll get to making our enclosure next week. We'll see how things go. So thanks for
Next
joining me,
week,
guys.
gentlemen.
Carl,
That was very cool, Carl.
Thank you. That was neat.
good stuff.
Good. Yeah, and like I said, this is a pretty simple first project, but we'll get more advanced later. Yeah.
Okay.
Once you
On
get
the
around, like,
record-
I'm sorry. Go ahead, Harold.
on the record, I'd be all about if like we did just a bunch of electronic stuff going forward.
Yeah, you know, Mike, I'm actually curious. I know you do radio stuff.
Yes.
I wonder if could we make a radio?
Shit. Nowadays they have a lot of SDR stuff. Back in the day,
Yeah.
most hams built their own rigs, or at least their own accessories. I built SWR bridges, automatic keyer, a lot of accessory stuff. I never built the transceiver.
Okay.
Well, I stripped apart television sets, took the vacuum tubes. This is back in the day.
Yeah.
But I mean, I built one tube transmitters of 10, 15 watts with a 6L6 or something with an FT243 crystal to stabilize the frequency. But you strip out a couple of televisions and old radio sets, and back in the day, you could make a transmitter out of that.
Huh. Yeah, I was
But
kind of
that's
curious to see if
500
we could
years
make a simple receiver, a simple radio receiver, but maybe it's not very simple. But
I'll have to
anyway.
look into it. I'm about 50 years behind times.
Well, 50
Actually,
years
probably more like 60 or 65 years.
50
behind
years
the
ago,
times.
that's the kind of radio that I want to make, though, you know? That's when radios were cool.
Okay.
Yeah. All right, we'll see you guys next week.
All right. Next
Thanks,
week,
Carl.
gentlemen. Thank you
Oh,
again. Goodbye.